All right, guys, welcome back, all three of you that are actually watching my videos. Today we're going to be talking about our assessment for this kind of sub-unit that we've been doing on the scientific method and experimental design. Typically, in a normal year where things aren't nearly as weird as they have been, students get in groups and design an experiment and we conduct them. But for many, many reasons, that's going to be difficult to impossible this school year. So what we're doing instead is everybody is going to design their own experimental protocol. And I'm going to show you an example of a complete one that I made up that y'all can take a look at. And I'll explain to you how I'm going to grade it and some of the things that I'm going to be looking for when I grade these. So your project, just keep in mind, you are not required to conduct the experiment this year. I'm going to say it again. This year, you are not required to conduct these experiments. It'd be overly difficult for a lot of folks to get the things they're going to need to do these experiments and then to film them and submit them. In a perfect world, that's what we do, but we're not in a perfect world. So you do not have to conduct them, okay? You just have to do the type of project I'm about to show you. So remember, this is going to be an assessment grade. A lot of the work you've been doing, like your daily work, has been between like 5 to 10, maybe 15 points. This is an 85-point project, just laying that out there. So make sure that you are doing your work, you're doing it completely. You actually click the little turn in button when you submit it, and that you're not doing anything that would make me have to not give you a grade, like copy off of someone else or something of that nature. So what you need to do, first thing you need to do is open a Google Slides presentation. I'm assuming most of you know how to do that, especially since we had a Google how-to video where I showed you that, but just in case you've gone brain dead since we last talked about that, let's just show you how to open it. So I opened a new tab. I'm at the Google screen and I see my little grid. I click it and it says slide. So you're going to need to open one of those. Okay. You will need to have at least one slide for each of the points below. You may choose to spread it out to more slides. Like if you have a lot of steps to your procedure, you might need more than one slide, and that's okay. But please don't try to cram all of this on one slide. Just know. You'll see when I show you mine. So choose one of the provided questions. If you have one that's not on the list, that could be fine. Just email me so I can approve it. Don't want anything too weird or inappropriate. So just get it approved if in doubt. Identify your variables. So when you get your question, figure out what you are testing, what you want to measure, what needs to stay the same, what are you comparing it to, all those sort of things. So now you need to make for step 4, we're making a testable hypothesis. Remember that predictions and hypotheses aren't the same thing. So for this step, I want you to put your hypothesis, a null hypothesis, and then I want a prediction. So I'll show you the difference if you don't remember on our example, but if you put all 3, that may be helpful for you. So testing your hypothesis. I know this seems like a lot of work, but you're going to be expected to design experiments later on. This was something that we do in AP pretty regularly. In the AP lab manual, they give you materials and roughly what you want to figure out, but the actual step-by-step, the actual experiments, you're expected to design yourself. So there's a reason why we are doing this. So you have to, now that you have your variables, you have your hypothesis, how can I prove or disprove it? What information do I need to gather? Because that's all an experiment is you're gathering information, you're testing something. So I need the materials required and I need a procedure of how I use them. So I tell students to think of this like a recipe. Recipes, I have one pulled up right over here. Recipes, they give you the ingredients, but they tell you exactly how much of each ingredient you need. In an experiment, it's the same way. I need to know how much of everything is required. If you don't know, that's okay. Make it up, all right? In your best judgment, how much would you need to do what you have planned? Like if you're testing a hormone or something, you know, how many injections or how many cc's or whatever, it's okay if you got to research that kind of thing. That's fine. Figure it out. I need the quantities. I need materials. I need what to do with those materials. All right, so determine what sort of data you need to collect. Is it sort of a yes or no thing? One student last year, they tested which cereal got mushy the fastest. So they'd have their test groups and they'd take a bite out of each one, and whenever they stopped being crunchy, they put down that time. Is that the sort of data you're gathering? Is it a positive or negative reaction? Is it a number? Is it time? Whatever it is, figure out what you need, what kind of information you're gathering, and then make a data table. And then you also need to set up a graph. I know you don't have the information to actually draw the line or the bars or whatever. I know that. I understand. But I still want you to set up the graph, and I'll show you in the example exactly how much I'm looking for. And then, are there safety concerns? If on your topic, is there some way you could get hurt or that the animal involved could get hurt? You need to know that. You need to put that on there. And also, how could you limit bias and prove your hypothesis is correct? So maybe you're going to talk about a chi-square test. Maybe there's a certain threshold, like if it's this much faster or this much hotter, then I believe there's a significant effect. So we need a standard. Okay, so some of our sample questions. Does the wavelength of light affect plant growth? Do mosquitoes spread the Zika virus? So you can see this list. Like I said, it's not comprehensive. If you have a really good idea that you just are dying to make an experiment about, send me an email and I can totally approve that. It's not a big deal. So let's look at our rubric, because I know there's a lot of you probably sweating right now. So the grading rubric. Your hypothesis is complete and testable. A working hypothesis, prediction, and null hypothesis are present. So both kinds of hypotheses and a prediction, that's what I'm looking for. It also needs to be testable. I shouldn't see words like better or good or things like that. I can't prove those. Those are opinions. It can't be an opinion. It has to be something I can prove. Is there math involved? Something. I have to prove it. Make sure your variables are identified correctly. If you get them swapped around or you identified the wrong thing, you will lose points here. Procedures are clear. Quantities are provided, steps are in order, and are able to be followed by someone unfamiliar with the experiment. So if you handed your experiment off to me, I should be able to read your write-up and I should be able to go in the lab and do it. So make sure that you are being exactly that clear. So you need a data table with a title and column and row labels. You need a graph. It needs a title, X and Y axis labels, and scales. Make sure you're addressing safety concerns. And I need to see that you know what acceptance or rejection of your hypothesis looks like. So if it's only this much more, then I know it's not really an effect. Like, you need to know that. And then your slide presentation needs to show effort. Your work needs to be neatly done and show that time was spent into completing it. I don't want to see some copy and paste off the internet shenanigans. I don't want to see you giving me a copy of someone else's work and passing it off as your own. I don't want that. So make sure that you are putting the time in so you can get your points there. And remember, if you copy work and cheat, you can't get credit for this assignment. It's an assessment. So let's take a look at my sample, just so you guys can see what this looks like. All right, so sample experiment presentation. I had to label it with AP because, as y'all know, your stuff's just a little bit different. So my question was, does chilling cookie dough affect how far a cookie will spread when baked? So about me, I didn't really make an about me video, but my first degree was actually in culinary arts, so baking is near and dear to my heart. So when I was throwing this together, I'm like, sure, why not cookies? So we have cookies. So variables. I want to know the effective temperature. of the dough. So that's my independent variable. That's what I'm manipulating or testing as a scientist. My dependent variable is what I'm measuring. So I'm measuring the spread of the cookie or diameter. And if you remember from math, diameter is like the distance across the middle of a circle. I have a control, which would be cookie dough, that is room temperature. So if I want to know if chilling affects it, I have to have some dough that was not chilled. That's what I'm comparing it to, so that's my control. So my constants, things that have to stay the same so that I know it was only temperature that affected the cookies. The size of the ball of dough, the type of dough. For example, Lacey's are a type of cookie, they don't puff up like at all. They just spread out completely flat. So you'll get, you know, like a paper thin cookie. Whereas chocolate chip cookies, you know, they can puff up, they can be tall. And you also want to make sure that you're baking them at the same time and temperature, or else that would affect your results. So my hypothesis. So my working hypothesis is that chilled cookie dough will spread less and produce cookies with a smaller diameter. So I stated what was, I stated a phenomenon. I stated what was going to happen. Null hypothesis. So my null hypothesis is that it's going to make cookies that are the same. And then a prediction is my if-then statement. So if cookie dough is chilled before baking, then it will produce cookies with a smaller diameter than room temperature cookies because chilled cookie dough spreads less. Remember, your hypothesis is answering your scientific question. All right, materials. You see that I have quantities on here. I have what weight of cookie dough I want to work with. I have how many baking sheets. Some of these tools you might not necessarily need a quantity for, but if there's something like cookie dough, ice, sand, whatever, it needs a quantity. Okay, procedure. So I go step by step. I tell you how much stuff goes in each step. So dividing the cookie dough in half, I tell you it's about 250 grams. Then when I make my cookies, I tell you it's about 50 grams in each cookie. So you know how much. I could hand this over to Miss Moore, Miss Smith, and they could do this experiment. That's what we're going for. All right, so a data table. Y'all may notice I'm missing something, so I'm gonna put it in real quick. You catch it? You catch what I did wrong? There's no title on my data chart. So let's fix that. Put diameter of cookies after baking. It's descriptive and it tells me what's going on with this data. So I don't have actual data in here because I'm not actually doing the experiment. That's not what's required. But I do have my data table all set up. So if I decided to go in the lab and do this today, I could do it. I have all my data tables ready. I've got my graph ready. So you know, I don't have bars, I don't have lines, I don't have dots. I just have this set up so I could do it if I had data. I've got my scale over here. My intervals are even. I have places for bars for both chilled and room temp. I have a title and I have labels. So this slide would get full credit. So safety concerns. If I did this experiment, there's an oven involved, so something's going to be hot. Make sure, you can read through this. I have my safety concerns listed, but then other considerations, anything else you need to put in there, like how to prove your hypothesis, things like that. So to confirm the data, chi-square testing could be used. I'm not expecting you to do that right this second. The test group should have a significant smaller diameter than the control group to accept the original hypothesis. If there is no significant difference, then the null hypothesis must be accepted. So I know at what point I pick which of those hypotheses if I did the experiment. So this is it. This is what you're expected to come up with. So going back to the graph real quick, there's a couple different ways that I would accept this. You can hand draw it, take a picture, and upload it to your slide. Don't send it directly to me. It needs to go in your presentation. I would accept that. or you can use the tools in Google Slides and make your graph that way. That's acceptable. Or you can use a graph generator. You can Google it and use that. But it's just whatever you're most comfortable with, but you have to have a graph set up here. And you have to have data table here. If you have any questions on how to do that in Google Slides, email me and we can get in a Google chat or something and I can talk you through some of that. If you don't know how to do something on slides, there's also a lot of helpful videos around on YouTube. So just look it up or ask me. If there's anything else that goes wrong or you start to panic or something, shoot me an email. Good luck. You'll have the rest of today and our class time on tomorrow to work on this. So happy hunting, guys. I will see you in the next video. Take care.